Hello, students. We've got to talk a little bit about the law of sines because it has some issues. In particular, it has issues with triangles that we know two pieces of information that are the sides and we know an angle. I'd like you to think back to geometry, and we had one congruence theorem that didn't work, and that was the SSA theorem. The reason for that was that if we knew two sides and then an angle between them, what ends up happening is we have the ability sometimes to make two triangles. I'm going to see if I can draw a pretty good example of this. So if I have one side and then an angle that I know, but I don't know how long that side is. But I do know how long the other side is, so the side in blue. The weird thing that happens is that I could also have a same length side make this triangle. So there are cases that we have more than one triangle able to be formed, and there are cases that we have an inability to form a triangle at all that give us some pause with law of sines. There's another weird thing that happens with sine that we're going to go into a lot more when we deal with trigonometry in a circle, but you're going to take a notice and you're going to see some weird things going on. So for example, if I did the sine of 60 degrees, when I do that, I get a number that's equal in terms of a decimal to 0.8660. If I did the sine of 120 degrees, so like we could be talking about the small angle versus this bigger version, we end up getting that same value. Again, this has to do with stuff we haven't talked about. We're going to talk about angles in a circle in the next set of videos that we look at. But this should also be a review from Algebra 2. So this shouldn't come as a surprise that sine has places that we have the same value. What I'd also like you to notice is that these two angles are supplementary. So if you have an angle, let's say the sine of 32 degrees, which I don't know the decimal for off the top of my head, the supplement of this angle would have the same sine value. So here we'd have 148 because these two things add up to 180. When we're trying to decide for these ambiguous case problems, this is what we're going to use to try to figure out what's going on here. We're going to check both of these possibilities and see which one works and which one doesn't. All right. So looking at our first problem, we're being given one angle. We're being given a sine value here. And what I'm going to do is I'm going to first figure out what this angle could be, and I'm going to do that using inverse sine. If you're using a program like Desmos, instead of writing sine with a -1, you could also use the word arcsine. This is another name for the same thing. That means sine inverse of this. So 0.9594. And that gives us 73.6 degrees. I can already see this is potentially a little bit problematic here, because if I wanted this to be 73.6 degrees, I've also got to figure out this angle and see if we can get that to work. And if we've got 109 plus 73.6, that already equals 182.6 degrees, which means that this third angle would have to be -2.6. Doesn't make sense in a triangle, so in this case that would be none. There are 0 values this could be. Just to kind of play with what would happen if we had to take this further, so as well as 73.6, I'm going to do 180 minus 73.6. And when I do that, we get 110 minus 3 is 107 minus 0.6, so 106.4. And we'd also have to do the same thing, 109 plus 106.4, which we can see is even further out of whack, plus some angle has to equal 180. We'd end up with an even bigger negative value here. This is just to show how we decide which angles, if any, will work. trying this again. I'm going to do the same thing that we did and immediately do the arc sine or the inverse sine and get that x could be 73.2 degrees. I'm going to call this x2, which would be whatever would add up to this to make 180, and that's going to be 106.8 degrees. The last thing I need to do is to check to see if these make triangles that work. So if I call this angle question mark up here, in case 1, we have 73.2 plus 21 plus question mark is equal to 180. And I can see pretty well that that's going to work for me. Those two add up to 94.2. And question mark would then be a number that works. So this will work as a triangle. Looking at the second one, we've got 106.8. We've got 21, and we've got a question mark. And we've got to add that up to 180. And again, this is going to work. This is going to be 127.8. There's stuff that I could add to that to get to 180. So there are two different triangles that would make this an okay fit. And that's what we're really looking for. We're not looking for what those triangles are, just the number of triangles we could get. One more of these, and we're going to start off exactly the same way. So 0.9683, and we're doing the inverse sine of that. We get x equals 75.5, and call that x1. x2 would be the supplement of this. So we're looking at 104.5 to get to 180. Okay, let's check these out and see if they work. 75.5 plus 67, make my question mark up there, plus question mark is equal to 180. Those two numbers add up to less than 180, so this is an okay problem. 104.5 plus 67, that's my other angle, plus question mark. Again, 104.5 plus 67 still adds up to less than 180. We're okay with that one as well. We don't have negative angles forming. Based on that, we have two different possibilities this could be. We also have to be able to use this in order to figure out what we could have as actual values for things. So let's take a look at that now. So we've got KLM, and we're told that K is 690 and that angle K is 46. I can already see we've got an opposite pair, so we're in good shape. And that L is 890. I should see a warning flag go off here. I've got an SSA relationship. This is a case that we might have more than one value. But let's kind of set this thing up. So I've got sine of K divide by 690. So sine of 46 divide by 690 is equal to, and I'm going to choose L because that's what I'm trying to find out. And when I do that, we've got sine of L divided by 890. Going to multiply the 890 to the other side and evaluate some stuff. And we've got 0.9278 is equal to sine of L. We know to get L, we've got to do an inverse trig thing. And when I do that, I got 68.1 degrees. Okay, and again, because we're dealing with potential for other possible things that might work, what we're going to have to do is then figure out what the other version of this angle could be, and that's going to be whatever would add up to 180 with this. So that's going to be 111.9, and just to make sure, I'm going to look at my triangle. So 111.9 plus 46, going to be less than 180. That makes it a possibility. And then we've got 68.1 and 46, definitely less than 180, so that would work too. These are the two possible values of L. I didn't do them to the nearest degree, so I guess that would be 68 degrees, and 112 degrees. We're not being asked to find the whole triangle, just the angles given this ambiguous case. All right, here's another one. We've got triangle UVW, and we're told that W is going to be 9, V is 2.2, and angle V is going to be 136. First thing I notice is that this is not a law of sines problem. I don't have any opposite things, so this is a law of cosine problems, which is actually a lot more helpful for us. We're looking for V, so I'm going to start with V squared is equal to, actually we're not even looking for V, we're looking for all possible values of angle W. So in order to do that, I do have to find V first. Let me backtrack again. So we're looking for, we got 9 squared plus 2.2 squared minus 2 times 9 times 2.2 times cosine of 136, which gets me V squared is equal to 114.325. Square rooting both sides, we end up getting a value of something that's rolled off my screen. Which is going to be 10.7-ish. So here's where the law of sines is going to come in. Now that I have an opposite pair of things, we're still looking for W. I'm going to have to use the law of sines to find that. And in looking at this, we're going to have sine of W over 9 is equal to sine of 136 divided by 10.7. All right, so let's do some math up. We get sine of W is 0.5842, and we know to find that we're going to do the arc sine, or the inverse sine of that, and we get W is equal to 35.75 degrees. I'm going to make an argument that we don't need to check the other version, but if you are not comfortable with that, the second W, so that would be at 144.25. The reason I said we don't have to check that second one is that immediately we can see that those two angles add up to more than 180. So that one doesn't work. 136 plus 35.75 is going to get us about 172. That would mean that we have a very small angle for U, but based on the 2.2 there, that makes sense as well.